Okay, thank you to all of you that sent me questions there from 12.4. So I'm going to start here with number 9, a frequently requested. It's like I'm a DJ or something. All right, so how much money would be invested every quarter at 10% per year, compounded quarterly, to have 5,000 in 2 years? How much more information can they cram in a single sentence? All right, so let's start by, again, let's get used to the variables that they're using. Our amount in the account at the final, we're looking for $5,000. It's compounded quarterly, so that means 4 times a year. So n in this case, if we're doing 4 times a year times 2 years, n should be 8 compounding periods. The annual percentage rate they tell us is 10%, so we'll take, and again, change that to a decimal, but since it's compounded quarterly, we're going to divide both sides by 4. So that'll give us 0.025. All right, I think that's pretty much all we need. We're looking for the regular payments. So that lovely little formula there, the regular payments are going to be the amount of interest per period. So that's the 0.025. Multiply that by the final amount, which we're hoping to save $5,000, times 1 plus I. So that'll be 1.025 raised to the 8th power minus 1. All right, so then it's, crunch the numbers with the calculator. So this is 572.34. Again, the power of earning some interest here. Every quarter for 2 years, that's only 8 times. And putting $500 into an account 8 times is only going to get you $4,000. But because of the interest, in the end, you're going to have an extra 1,000. All right, for 13 then. How much money must be invested now, 9% per year, semi-annually, to fund an annuity of 20 payments of $200 each, paid every 6 months? Again, that's another way of just saying semi-annually. The first 6 payments being 6 months from now. So we're putting in, or we're looking for regular payments. That's the R of 200. To fund an annuity of 20 payments, so N is 20. The interest rate is going to be, again, take the percent, change that to a decimal, 0.9. Semi-annually means divide that by 2, so 0.045. All right, so the amount we need to put into the present account, we're going to take R, which is the 200, and multiply it by our lovely fraction here, where we're going to take 1 minus 1 plus I, so it'll be 1.045. Raise that to the negative nth power, so that's negative 20 over I, which is 0.045. And again, you can crunch the numbers there, careful. $2,601.59. So if we can come up with that money, put it in an annuity right now. So it's going to be, for those first 6 months, they're going to pay you 9% interest, 4.5% interest on that, the first compounding period, but then it's a payment of $200 at that point, and $200 every 6 months after that for 10 years. All right, 17, yay, the word that strikes fear into most adults, mortgage. We're looking for the monthly payment on a 30-year mortgage, $100,000, 8% interest per year. As usual, it's compounded monthly. And then here's the really shocking, the total amount paid on this loan. All right, so we're going to start with the present amount is the $100,000. The value here for I, we're going to take 0.08 and divide that by the 12 monthly payments. So that's going to be 0.00666666 repeating. And I think we've talked about 30 years, 30-year mortgage, monthly payments, 360 payments. All right, so our regular payment formula tells us we're supposed to take the interest, so the 0.0066666666 repeating, multiply that by the present amount. We're looking for a loan of $100,000. Now again, here's the denominator gets kind of tricky. 1 plus I, so that'll be 1.00666666 repeating, raised to the negative 360th power. So again, just be extra careful about how you're typing that in. Put a set of parentheses around the denominator. Not always necessary, but certainly not too cumbersome. Most of the time, it'll save you some frustration and aggravation. All right, well, again, I'm not sure how much your paychecks are these days, but $733.76 is going to be paid to the mortgage company every single month for the next 30 years. Doesn't that sound like fun? All right, so that's the first part here. The second part, hopefully you have calculators. If we're paying $733.76 every month for 360 months, so there it is. If you want to take out a mortgage and buy a house that's worth $100,000 now, or at least you're taking out a $100,000 mortgage, maybe you've saved up for a down payment yourself. In the end, you're going to pay back to the mortgage company a total of $264,153.60. So you're paying back the original $100,000 that you're borrowing, and you're paying more than twice that amount in interest. These are the realities, folks. Doesn't that make you just want to rush into adulthood? All right, 21. Suppose we're going to save up. Jane agrees to buy a car for a down payment of $2,000, and then she can afford payments of $220 a month. She wants to pay it off in 3 years. If the lending company is offering her an interest rate of 8% per year, monthly payments, compounded monthly, the actual purchase price of her car. So we know that the regular payments are going to be $220. The value for I, take the interest rate, change it to a decimal, divide by 12. Gee, this number sounds familiar. And the number of payments monthly for 3 years, 36 payments. So we're looking for the present amount. So it's going to be our regular payment of 220 multiplied by a lovely complex fraction here, 1 minus 1 plus I, so that'll be 1.006 repeating to the negative 36th power, all divided by I, 0.006 repeating. So carefully typing that in, $7,020.60. Oh, but wait, she can make a down payment. If you're making that down payment, you're lowering the price that you're paying for the, well, you're not really lowering the price. You're lowering the amount due. That's $2,000 that you don't have to borrow because you've saved it. The agreed upon selling price of the car is $9,020.60. She puts $2,000 down, so that lowers the amount due down to about a little more than $7,000, and she borrows that, pays it off in 3 years. Congratulations, Jane, the car is yours. All right, multiple part question here for mortgage. Again, 30-year loan, $100,000, compounded monthly. Okay, so we know we've seen this before. N is 360. Of course, that's monthly for 30 years. The present value is $100,000. Our interest, taking the 0.0975. Well, thank goodness for once they actually changed that number for us here. So the monthly interest is going to be 0.008125. Okay. So if we're looking for the amount of their monthly payment, then that's again the R, the regular payments here, are going to be the rather long interest. Be accurate. Don't round that off. Please don't get lazy. Over, then 1 minus 1 plus the interest rate, so it'll give us 1.008125 raised to the negative 360th power. Crunch those numbers there. That works out to be payments of $859.15. So again, part B, very similar to what we saw earlier. $859.15 per month for 360 months will be $309,294. So if we could just, I'm sorry, here's the monthly, here's the total amount. Just comparing here before, no, part C, I haven't done that yet. Just comparing here 23 to what we looked at with 17. Same amount, same monthly payments, same term of 30 years, 8% interest compared to 9.75% interest. That's a big difference there in the amount of interest that's being charged. Okay. All right, then for part C, instead of taking the loan, they deposit those monthly payments, okay, the ones that we just found here in part A. We're taking that money and we're putting it into an account that pays that exact amount of interest, same term monthly, same 30-year period. So we're looking for the final amount. If we take the 859.15, the regular payments, we'll take 1.008125 to the 360th power minus 1 over the interest, 0.008125. Bonus points if you can hear the music in the background and you just did the little drum solo. It's worth more than almost $2 million, $1,841,519.29. Okay, this is this is just the tip of the iceberg when it comes to your personal finance, boys and girls. All right, 25. Hopefully you recognize the little calculator icon off to the side there. That this one is, you're going to need to graph this to solve it. Okay, that's the little hint that they're giving you there. Like they didn't do this in an example earlier in the chapter. China buys a stereo system for $640. He agrees to pay $32 a month for 2 years. Supposing the interest is compounded monthly, what's his interest rate? Okay, so we know the amount that it's presently worth is $640. We know his regular payments are $32. And the number of payments, okay, monthly for 2 years, that's 24 payments. So 32 is equal to the interest that we don't know times the principal, or sorry, the amount of present value over 1 minus 1 plus I to the n power. All right, so what's up for this? Now we've got to solve this for the interest rate. Let's just off to the side here, let's define x is, we're going to solve for the interest rate. But we know since this is compounded monthly, x is going to be whatever I is, which sounded like really bad grammar, divided by 12. So 32 has to be equal to x over 12, solving that for I, times 640 divided by 1 minus 1 plus x over 12 to the negative 24th power. My, what a mess that is. And again, if we're going to try and solve this with your calculator, oh my goodness, guess and check is probably not the best way to go. We're actually going to solve this by graphing, finding the point of intersection. How's that sound? I guess I could just add a new page there. All right, so for my goodness, that numerator is just wonderfully complicated. So we'll take x divided by 12. I'm going to put that inside a set of parentheses times 640 divided by, now I want a new set of parentheses here, 1 minus, more parentheses, 1 plus x divided by 12. Close that set of parentheses around the fraction. Close a second set of parentheses because it's 1 plus the interest rate. Now we need to raise that to the negative 24th power. And that's all one denominator there. Now let's check. The calculator will convert this to the rather tedious way that I had to type it in. Let's check with our lovely little formula there and make sure that everything worked out nice. That's all right. Great. So that's one. How do we solve this by graphing? We're simply going to take the other side of the equation and graph that as a different function. So, well, okay, again, tab to get to that. 32, a nice horizontal line. Where to go? So for Windows Zoom, how about we choose a Zoom Fit? Okay, so there's our. Now, again, what are you expecting as far as the interest rate is concerned? I'm expecting something here that's a relatively small number. So you can mess around with the window as much as you need to, so that you can see where those two graphs, those two functions intersect. And then it's just a matter of, we're going to analyze the graph. We want to find the point of intersection between here and here. Now, hopefully that doesn't come as too much of a surprise that the y coordinate is 32. That's a point of intersection with that nice, in my graph here, the red horizontal line. All the y coordinates have to be 32. And again, the way the Texas Instruments calculators function here, they're only going to go out to 3 decimal places. It actually goes a little bit further than that. But if we can solve that and say that the approximate interest rate there is 0.182, boom, boom. Again, we solved that. So I is, approximately equal to 0.182, which, okay, to be consistent with what we've done before, we really should take that and convert that into a percentage. To say he's paying about 18.2%. Okay. And then we're going to do almost the same type of thing here with number 27. So the amount that it's presently worth is $189.99. Our regular payments here, $10.50. And the number of payments was given to us as 20. Now again, we're going to do the same thing here. If it's compounded monthly, then x is going to be I divided by 12. So we can say our 1050 is equal to x over 12 times the 189.99, 1 minus 1 plus x over 12 to the negative 20th power. Now, by virtue of the fact that we went ahead and typed this tedious thing in here the first time, let's just go back and edit. And hopefully that's acceptable. Because again, this problem here, very similar to what they did as far as the monthly payments is concerned. So that x over 12, we can just leave that, 189.99. And this is the same, 1 minus the quantity, 1 plus x over 12, but instead of to the negative 24th, it's the negative 20th. Hit enter. But again, go back to tab, up arrow. The regular payments now are 1050. You understand you don't have to hit that last zero. And would you look at that? Because I already have that intersection function turned on. As I adjusted my equations, it automatically recalculated that point of intersection. Isn't that nice? So again, take the 0.117, change that back to a decimal, approximately 11.7%. All right, I hope that helps. Again, these are really technical. These are, as you saw, in some cases tedious, but I'm sure you guys will persevere. You know how to deal with it.